Hello everyone, I'm Alessandro Frigeri from ENAF in Rome, Italy, and I want to discuss about the importance of geologic maps for resource evaluation and landing site modeling. So next slide. So in the 60s, that was the situation. So lunar exploration in the 60s was basically made by two main actors. The space agency were governmental, and there was the US and the Soviet Union. Next slide. Nowadays, this situation is completely different. In this map, we see reported all the space agency abroad in the globe. And among them, a good number, they have ongoing mission to the moon programs, or at least a program to explore the moon. This means that we have to decide if and how can we be interoperable in terms of geologic mapping for the moon exploration. Next slide. And this concept is important because the geologic maps is a kind of product which is demanding and time-consuming, let's say. So I want to recall the logic behind geologic mapping. So geologic maps are basically made from actual data products, processed product, and the minimum set of maps to produce a geologic map is made by an image mosaic, or generally speaking, a radiometer response of the surface that allows to extract information about the composition of the surface. And then for geologic mapping, we need the topography. And the topography is needed to understand the stratigraphic relation of these different materials. So this synthesis result in the geologic map. And the geologic map is a process that requires work and requires discussion and requires also a review, because it is a kind of logical construction of this synthesis of actual process data. But the good thing is that a good geologic map can be literally cut to understand what is beneath that. Next slide. So if we cut the geologic map of the slide before, we obtain what we saw yesterday in the Wilhelm's diagram about what is a geologic map in 3 dimensions. So the geologic map gives us also the information about the volumes of rock which are in the underground. And beside the volumes of rock, we can observe also the spatial relationship between these volumes. And these spatial relationships gives also a logical sequence of emplacement of these volumes of rock. So the geologic map adds the third spatial dimension to the map, but also the time scale, the time sequence of events, or the processes that produce a particular geologic situation nowadays. So geologic mapping is very important and is really crucial if we want, for example, to test scientific hypotheses. But beside that, geologic map is also important for applied sciences. Next slide. Next slide. Okay, so applied sciences means that we use the geologic map to produce some derived products or to study some specific aspect of the exploration we are doing on the moon. So, for example, for resource evaluation, we speak about materials, volume, and accessibility to these materials and volumes. So, for example, if we want to use the geologic map for resource evaluation, we can assign composition, density, cohesion to the geologic unit. And in this case, we can produce some derived product useful for resource evaluation. In the same way, we can use geologic maps to produce theoretical and numerical modeling. So for example, we can use the geologic unit and assign acoustic impedance or thermal behavior to the units and produce theoretical or numerical models which allows to understand the physical behavior or to predict what is the mechanical behavior at the landing site. So geologic maps are very important for this kind of studies, and we have to have accessibility to that. Next slide. So this is what can be done today, because we have, for example, this geologic map at 1 to 5 million scale from Forteso and colleague 2020. And in this case, we have the South Polar region with all the candidate landing site, candidate Artemis landing site. So, for example, we can use this. We have this available, and we can use it for study the Artemis, for example, landing site. So, in the case of Amundsen Rim landing site, next slide, we can use this map, and we end up with this map. A large-scale map which ends up with a single unit, which is not very informative. In fact, as we saw also yesterday, the jump between the global scale, the small scale, and this large scale landing scale mapping is too big. It's too big to have a context where we can place our geologic mapping for example, a landing site mapping. So next slide. So it is important to have a kind of mid-scale map to give context to our site-specific mapping, geologic mapping, and modeling. And this mid-scale map is also strategic because once we do the large-scale mapping, we can update or we can assess this mid-scale map, which in turns, again, can be really useful to assess what is the global geologic maps once our knowledge has been increased by, for example, new knowledge given by new mission. So next slide. So the conclusion is that for resource evaluation and geophysical and physical modeling, we need a new generation of geologic maps of the moon. These maps have to be accessible to a broad audience, and this accessibility has to be guaranteed before, during, and after the mission. And for doing that, the maps have to be digitally published. I mean, not only as graphics, but also as interoperable geospatial data. And this data have to be citable like we do with the papers, and we are doing with open data nowadays. So if the data are digitally published, it means that it can be reusable. Reusable data means that we can use geologic maps to do derivative products like resource evaluation with engineers. Or, for example, we can produce models, 3D models of the seismic response of the moon or thermal behavior with physicists and mathematicians. And in turn, the reusability of geologic maps implies also that once we have more knowledge of an area, we can improve the geologic map of the same area starting from the previous version of the map. All these conditions have a positive side effect, that technically all this condition enables us to make some international effort possible, like, for example, coordinated mapping campaigns or something that shares the workload and avoid to reinvent the wheel in this challenging exploration on the moon. So that's all. Next slide. And that's all I wanted to say. I leave you the contact if you want to further continue the discussion, and thank you.